methods, we have diverse formulas, like the Newton-Raphson's iteration formula, which is x subscript n plus 1 is equal to x subscript n minus f of xn over f prime of xn. Now, what I'm doing is to state some formulas acquainted with numerical methods. Now, Newton-Raphson's iteration formula, when we are to increase ahead with 1, for example, if we count 1, the next value is 2. So when we are to count 2, we start it from 1. So it means x subscript n plus 1 is equal to xn, s subscript n, minus f of s subscript n divided by f prime of s subscript n. Now, we also take a look at the Simpson's rule, Simpson's 1/3 rule. That is h over 3. H is the step size, all brackets, the sum of the first term and the last term. Now, plus 4. Definitely, we are having 4 multiplied by the even numbers. That is in consecutiveness of the iteration, the numbering. Then plus 2 multiplied by the odd numbers. So we talk about Simpson's rule formula as h over 3 into the sum of the first value and the last value plus 4 multiplied by the even numbering, not numbers, in the consecutiveness, in the chronology of numbering, all the even numbers, sum the values together multiplied by 4 plus sum the values of the odd numbers multiplied by 2. Yes, then all in brackets multiplied by step size h over 3. That is referred to as Simpson 1/3 rule. So we also have the Lagrange interpolating polynomial. Lagrange is denoted by letter L. So of course, when we look at Lagrange's formula, polynomial x, p function of x is equal to f naught multiplied by L naught plus f1 multiplied by L1 plus f2 multiplied by L2. That is quadratic interpolating polynomial formula. You can also say that p function of x is equal to f of x naught multiplied by L naught plus f of x1 multiplied by L1 of x plus f of x2 multiplied by L2 function of x. That is quadratic interpolation, having x0, x1, and x2 as its limit value or boundary values. So the second rule, which is synonymous with root method, like the Newton-Raphson's iteration formula. The Newton-Raphson's iteration formula is comparable to second formula because they are used for root method functions. And of course, this connotes to the formula as x subscript n plus 1 is equal to x subscript n minus f of x subscript n into x subscript n minus x subscript n minus 1 divided by f of x subscript n minus f of x subscript n minus 1. I repeat again, second rule formula. Xn plus 1 is equal to xn minus f of xn into xn minus as f of xn into xn minus x subscript n minus 1 all over f of xn minus f of x subscript n minus 1. So you take note that all the n are subscript. That is second rule formula. It is very key in numerical method. Take note of that. These formulas are fundamental and they are very useful in numerical method. Take note.